Welcome to this course on Elements of Mechanical Engineering. My name is Atchuta Ramacharyulu and I am working as an assistant professor in the Department of Mechanical Engineering in the College Institute of Aeronautical Engineering. We are currently studying the Elements of Mechanical Engineering. This is a course which is offered for Aeronautical Engineering and Civil Engineering, where we are in the fifth module. We are studying the automation systems. There are mainly two kinds of automations that are possible in the manufacturing industry. So the first one is how we manufacture different things using automation, like CNC machines. And second one is robots. So we are studying robots. We have seen in the previous lectures what is a robot, what is the anatomy of a robot, what are the different components of a robot. So out of the different components, we have seen a robotic sensor. In this lecture, we are going to see what is a robotic sensor and how it is used for functioning of the robot. See here. A robot sensor is the device which informs the controller about the actual functioning of the robot. There might be two kinds of sensors. One is internal sensor and the second one is external sensor. So the internal sensor will tell you how the machine is working, like whether the machine is moving at the rated RPM or not, whether the machine is working or any malfunctions are there, any failure happens in the machine. So here I mean the machine refers to robot. Okay, we are studying the robot sensors. So these sensors are used for robotic functioning. Internal sensors will tell you the information about the different joints and links of the robot, like which position they are and how the position of each link with respect to another link. So this data is given by the internal sensors. And some sensors are there which are connected with the environment around the robot. So they can contact or they can gather information from the environment or the surroundings around the robot. So they are called as external sensors. So some external sensors, what they will do, they will generally collect the data like force, torque, vision, touch, pressure sensors. So these are some of the examples of internal sensors, and the examples for internal sensors are position sensor, velocity, acceleration, etc. So position, velocity and acceleration, these are the parameters that are directly related to the links of the robot. So they can be calculated or they can be studied. That information can be studied with the help of these sensors. So let us see. There are some internal sensors and external sensors. Both sensors will give the information regarding the internal working of the robot or external environment of the robot. So this data will be given to the controller. The controller will process the information, like whether the robot is moving at the rated RPM or it is moving at the rated speed. Then it will modify accordingly and it will think using artificial intelligence whether the machine has to continue working in the same manner or it has to change the path of the robot. External sensors will give you the information about how the force is being lifted or applied by the robot, or we can see what object is placed in front of the robot with using vision sensors, and we can use touch or pressure sensors to identify a object by physical touch of the robot on the object which we are moving. So these are the robotic sensors. We'll see in detail. First one is position and velocity sensors. Suppose I have a robot. This is the base of the robot. On this, a robot is fixed. Robotic link is fixed. It has a joint on which another link is there. So this is link 1 and link 2. This is joint 1 and joint 2. So these are two links which are connected by a joint 1. This joint. So if I want to know what position the link 1 is with respect to link 2, Here we can see the link 1 is fixed, this one is fixed, and link 2 is movable. Now, the fixed link does not move anywhere, but it has a second link which is jointed with the help of a robotic joint. So about this joint, the link 2 can rotate. The link 2 can rotate in this direction. Even though it has some constraints, it cannot rotate all the 360 degrees, but it can rotate about some angle. Now, if I want to measure how much angle this robot has rotated, how much angle has rotated by link 2 with respect to link 1, I have to use some kind of measuring device, because every time I cannot go and measure with a plastic scale or a protractor. So I need an electronic device which gives this information to the controller. So at this point, I will use a sensor named potentiometer. Now we'll see what is a potentiometer and what is the working, how does the potentiometer work. So we'll see all these things in detail. Now, so far we have seen a sensor is a device which can detect position or velocity of a joint in robots. We have two links, these two are connected at a joint. At this joint, I will connect this sensor to measure the rotation of the robot. It can measure the position. Position means it can measure the angle, or it can measure the velocity of the link 2 with respect to link 1. It can measure both the things. Okay. Now we'll see how this potentiometer work. So potentiometer is an analog device which output voltage is proportional to the position of the wiper. So here the working of the potentiometer is completely based on the voltage. The output voltage directly proportional to the position of the wiper. Now we'll see what is the wiper which is being used in the potentiometer and how does this wiper works. Now see, here we have a diagram. This is the block diagram of the potentiometer, where we can see there is a circular coil which we are calling it as a casing. So there is a circular casing. Inside the circular casing, there is a resistive element. Here we can see this is the resistive element. The zigzag diagram is called the resistive element. So this resistive element is nothing but it is a resistor. It will not allow the flow of current into the circuit. Okay. And this resistive element is connected to a battery or a power source, where it is connected and some voltage is applied to the potentiometer. Now, the voltage will be, or the current will be passing through the resistor, this resistive element, inside which I have a wiper. So this object is called as wiper. Okay, what does this wiper do? It will simply kept in contact with the resistive element, and this wiper can rotate in 360 degrees centigrade. So when the wiper rotates, so this wiper is directly connected to the joint of the robot. Okay, this wiper is directly connected to the joint, so that if the link 2 moves through some angle, this wiper also rotates along with that link. So with the help of this, we can directly measure how much angle the robot has rotated. See, we'll see the working. Whenever this wiper is moving from this point, let this point be A. Previously, the wiper is at point A before the starting of the motion of the link 2 in the robot. The wiper is at point A. Now, the wiper has rotated to point B. Now, it is at point B because of the movement of link. Now, this point A, which indicates there is a full voltage supply. Here we can see the voltage is directly taken to the output of the potentiometer. when the voltage is completely transferred to the output, when the wiper is at point A. Point A, maximum voltage. Okay, which means whatever the voltage that is given into the potentiometer, the same voltage is coming out of the potentiometer. So at point A, the voltage is maximum voltage, which is same as the input voltage. Now, if the wiper has rotated through some angle and it shifted to point B, now what happens? The part, here we can see the part between A and B, there is a resistive element which does not allow the flow of electricity. So it will decrease some voltage. So at point B, the voltage will be somewhat less, VB, which is less than VA. I can write this as VA. Okay, voltage at point A is VA and voltage at point B is VB. So VB is less than VA. Now the difference in this voltage, VA minus VB, the difference of this voltage will be taken as the voltage difference, which will, with the correct calibration, we can measure the position of the robot by using this voltage difference. So the potentiometer is calibrated in such a way that the voltage difference between A and B, point A and point B, is taken and it is given to a formula. We'll see what is the formula in the next slide. And this formula will give you the actual position of the how much angle the link has rotated. Okay. A voltage is applied across the resistive element. The voltage between the wiper and the ground is proportional to the ratio of the resistance on one side of the wiper to the total resistance of the resistive element. The pot acts as a voltage divider. See here the casing, which we have said before, the casing is also called as pot. Okay. Now we'll go to the next slide. The voltage across the resistive element is divided into two parts by the wiper. Now, measuring the voltage, we have to measure the voltage, and this voltage will give you the rotation or the angle through which the robotic link has rotated. See here, V naught T. V naught is nothing but the difference of voltage. Here, V naught is the output voltage. Okay, it is written here, V naught is the output voltage. So whatever the voltage that is coming out of the potentiometer is taken as V naught, which is a function of time, and Kp is a constant of the potentiometer. Every potentiometer will have a constant value which indicates its calibration with the, and it indicates the property of the resistive element. So Kp is the constant of the potentiometer and theta t is the angle. So theta t is the angle of the potentiometer which it is rotated, because the potentiometer is connected to the link of the robot. When the robot is rotating, the wiper of the potentiometer also rotates and it will measure some angle. Now using this formula, we can calculate the angle through which the robot has rotated. So see here, so in this formula, V naught is the output voltage, Kp is the constant of the potentiometer, and theta is the angle rotated by the wiper inside the potentiometer. See, this is the basic principle of a potentiometer. It can be used for measuring the position. That means in the form of angle. So the movable object is connected directly to the rotational shaft or slider of the potentiometer. So the wiper, which we are calling it as a movable object, it can be connected to the rotational shaft or slider of the potentiometer, and the potentiometer wiper will vary output signals from 0 to 10 volts. So it can measure a voltage from 0 to 10 volts only. Okay, so it can measure very small voltages, but it can measure position from some like 0 to 180 degrees. Okay. So here we can see If the potentiometer is rated as 10 volts, if the potentiometer is rated as 10 volts, if the wiper is at the halfway position in the circular pot, here we can see in this diagram, if the wiper initially it is at point A, if the wiper is at this position, point C, then the voltage inside the potentiometer, which is coming out of the potentiometer, will be half of the actual value. So if the potentiometer is rated for 10 volts, if the wiper is halfway through the potentiometer resistive element, then the voltage will be 5 volts. It is simply half of the voltage. Now, this is how a potentiometer works. The potentiometers are mostly used for generating analog signal. So they can generate a analog signal which is given into a transducer, which will convert the electric signal, and this signal can be taken to the controller. Okay, so that the controller will measure with what angle the robotic link has rotated. Okay, so there are some disadvantages of a potentiometer. First one is because we are using a moving element, and we are using some kind of wiper. So what happens is, this wiper, when it is rotating along the resistive element, what happens is it will create some because of the friction between the wiper and the resistive element. Okay, so this is wiper and this is resistive element. So whenever the wiper is rotating along the resistive element, it will create some noise. Okay, it will create some noise due to the friction between wiper and the resistive element. And one more disadvantage is the output coming from the potentiometer is very non-linear, because it does not follow any linear path when the output from the potentiometer is coming. Okay, so these are the disadvantages of a potentiometer which is used for measuring the position. Apart from these disadvantages, the potentiometers are very useful in measuring the position and velocity of the robotic joint. Next, position measurement. Now, to measure the position of the robot, we have used potentiometer. Now, we have another device which can measure the position at through which angle the robot has rotated. So, for this, we are using another kind of sensor which is called optical encoder. Optical encoder. So, this optical encoder is very important. So, the optical encoder is used to measure the rotational angle of the motor shaft. So, this optical encoder is directly connected to the motor shaft where two links are connected at the joint. Okay. So, this optical encoder will measure the rotations of the joints by using a technique, by using light source. Okay. So, we will see how the optical encoder will work. So, it consists of a light beam, a light detector, and a rotating disc. So, these are the key components which are used for measuring the position by using a optical encoder. So, we will have a light source and we will have a light detecting sensor, and we have a object called a rotating disc. Now, see, this rotating disc has slits. Okay, slits are now this rotating disc has slits which can be passing light through them. Okay. Now see here, uh, this point is over. The grating consists of black lines separated by clear spaces. Okay. So the slits or holes made on the circular disc are also called as grates. Okay. Now the grates consist of black lines and slits separated by clear spaces. So the width of the lines and spaces are same. See, the principle how it works is, when there is a line coming out of the signal, when there is a line, that means cut the beam. When the light is not allowed to pass through the disc, then there is a signal, no signal. That means there is no light coming from the optical encoding disk, which means there is the output will be a low signal output, where we will consider that as a line. Okay. And if the light is allowed to pass through the disk, then we will consider this as a high signal output, and we will get a space while we are encoding the signals. So see here, a train of pulses is generated with rotation by the disk. By counting the pulses, it is possible to know the rotation angle. So when we make the light flow through the rotating disk, we can know that the light is being passed. If the light is stopped by the disk itself, because there are multiple holes and some places where there are no holes. So when there is no hole placed between the light source and the sensor, then light will not pass through the rotating disk. Then we will have a blank, which indicates a cut the beam, which indicates as a low signal. When there is a light flow through the disk, then it is called as high signal output. Now see here, we will have like a series of light. This line indicates a no pass through the disk. Then we will have some space, and again we will have some line, and again we will have a space, and then we again have a line. So measuring the pulses, so we will have a line, space, line, space, line. So this indicates the different pulses coming out of the sensor. So counting these pulses, we can measure the rotation of the position of the robotic link. Okay. So with the correct calibration, we can measure the movement of the link. Now we can see here, there is a diagram for optical encoder. See here in this diagram, so this is a light source. So here the center we have a disk. This disk has these black color lines are there. These are not parallel to each other. I mean, different zones are there on this disk where there are black lines. Black lines indicates a hole in the disk, and there are white spaces where there is no hole, because that means light cannot pass through that white space. So black space, holes, white space, no holes. So this point where we will have a light source. On the left side we will have, so these two are the light sources. We have two light sources. On the right side we have two light sensors. So these are photo transistors or photo detectors. So they can detect the light. So whenever the light is made to fall through the optical disc, when there is a hole, the optical disc will allow the light to pass through it, and this light will be sensed by the photosensitive detectors. Okay, so we will first calculate a space. A space is generated because the light is allowed to pass through the optical encoder disc. So we have generated a space. So this is a high output signal. And then when the disc has rotated to some angle, now the position of the light is in such a way that it is not able to pass through the disc. Okay. So what happens is, when there is no passage of light through the disc, what happens? The photo detecting sensor will not detect any light. So it will simply gives a line. So we have a space and then line. And then again, if the disc has rotated through some more angle, we will have another space. Now what happens is, measuring these order of space lines signals, so we can actually measure the angle through which the robot has rotated. So here, from these sensors, we will get a sinusoidal waves. So these are the digital output signals where we will get the sinusoidal waves. So we can measure this with the help of a optical encoding sensor. So this entire thing is combinedly called as optical encoding sensing device. So we'll see what is the basic definition. Optical encoders operate by counting scale lines with the use of a light source and a photodetector. They usually transform the light distribution into two sinusoidal electrical signals. that are used to determine the relative position between a scanning head and a linear scale. So every time we can see there are two sinusoidal signals generated by the photodetective sensors. So they are sent into a modifier and then they are calculated how much angle the optical encoder has rotated. Now we'll see next kind. So this is a sensor which is used for measuring the force and torque. Now see here in the previous slides we have seen how to measure position with the help of two kinds of sensors. One is potentiometer, second one is optical encoder. So both are used for measuring the internal position or internal acceleration or internal velocity. We can measure three things with the help of potentiometer or optical encoders. So these two are internal sensors. Potentiometer and optical encoders both are internal sensors. They can measure position, velocity or acceleration. Now this sensor, the sensor we are seeing now, it measures force or torque. We know force is the from strength of materials or mechanics of solids course. We can say force is nothing but the load applied on a unit area. So in order to calculate the force or the stress in a body, we use a device called strain gauge. See here in this picture, we have a metal part. This is a mechanical element on which a yellow colored strip is attached and it is connected with wires. Now what happens? What is this device and how does it works? Simple. We know stress and strain. What is the formula for stress? Stress is nothing but load by area. Load by area. P is the load and A is the cross-sectional area. And strain. What is strain? Strain is nothing but change in length or a change in dimension by original dimension. I take the example of length here. Okay. Delta L by L. Delta L is the change in length of the object divided by L is the actual length of the object. Now using the stress strain relation, we can calculate any value, like we have a relation between stress and strain, that is Young's modulus. Young's modulus is equal to stress divided by strain. So if we want to calculate the stress or strain value out of these three things, we should have any two values. Okay. So if I want to calculate stress, I need strain value and Young's modulus, that is capital E. So capital E or Young's modulus is the property of the particular metal. It is predefined because the metal with which we are working is fixed at the beginning of the experiment. So Young's modulus is fixed. Now we have to know what is the strain which is being applied on the body. Now to measure this strain, we use a device called strain gauge. This yellow colored patch which is attached to the metal body is called strain gauge. Now we'll see what is the working of a strain gauge. It's simple. The strain gauge is also made up of a metal which is very thin layer of metal. This metal is attached to the body for which we want to calculate the deformation. So we will know initially what is the length of the object. Initial length will be known because it is a predefined value, initial length of the object. Now we will find whenever there is a load applied on the object. Now if I apply some tensile load on this object, I am pulling the main metal object towards both sides. Now I am applying some load on the object. Now whenever I apply some load, the body will be deformed. Deformation means the length of the body will slightly increases. This is very minute, but this can be calculated or recorded with the help of a strain gauge. Now I have seen initial length of the body is L, change in length of the body is delta L, which is given by the strain gauge, because the strain gauge is a small thin patch which is attached to the body. This patch will elongate along with the main surface body. Okay, now the deformation will be calculated by using the strain gauge. Now we will get delta L value. Now this delta L is used for calculating the strain. Delta L by L is equal to strain. Now this delta L by L is nothing but the strain. The strain value can be directly used in the formula capital E is equal to stress by strain. Stress divided by strain. We will get the stress value. From stress, we can easily calculate by using the cross-section area. If we have the stress value and we know the cross-sectional area, we can easily calculate the load on the body. Okay. Now, these are force or torque sensors. Now, the value which is taken from the sensor is given to a computer. This computer will calculate all these calculations. It will do the calculations and it will give you the final output, whatever the output we need. Okay, like if I want the pressure, if I want the load which is being applied on the body, I can calculate that. Or if I want to calculate the stress which is being developed inside the body, I can calculate that value by using these calculations. Okay, by using the strain gauge, we can get any value. We can calculate stress, strain, load, etc. Or we can calculate force and torque also. By using the load, we can easily calculate force or torque. Depending on the type of loading, we can calculate torque and force also. So these sensors are used to measure the joint forces and torque by using a strain gauge principle. The change in the resistance of the electrical strain gauge affected by strain due to change in the force induced in measure of the force and torque. Now we are actually studying the principle of the strain gauge. See here in the second paragraph, it is given the change in the resistance of the electrical strain gauge. Whenever there is a change in the resistance of the strain gauge, which is affected by the strain. Okay, how the strain gauge is affected? Because it is elongating, it is being deformed along with the main body. So, due to the change in the force given in the body, we have applied some load on the body, and the strain gauge is also deforming along with the main body. So, when there is a change in the shape of the body, the strain gauge also will expand. With the expansion of the strain gauge, the resistance will increase. With the increased resistance, we can measure with the help of a formula, we can measure how much the body has elongated. So this is how force or torque sensor will work. And so this is all about robotic sensors. So far we have seen what is a sensor and how does a sensor work. We have seen two kinds of sensors. One is internal sensor and second one is external sensor. So there are two types of sensors. So examples for internal sensors are potentiometer, optical encoder. And second one is external sensors are strain gauges. And some more examples are there which we will see in the next lecture. Vision cameras, etc. So these are the sensors which are used for measuring the feedback, how the systems are working inside the robot and outside environment which is being working around the robot. So we can measure both information using internal or external sensors. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.